For decades, the path into software development, a company hired someone who did not know very much. That person received small tasks. Fix the button, write the test, update the documentation, change the form, clean up the database query, find the bug, ask questions, break something, learn why it broke, watch a senior developer repair the damage, try again. The work was not glamorous. It was the ladder. Every senior engineer once stood on the bottom step. The junior developer did not become valuable because the first tasks were important. The tasks were valuable because they created experience. A small bug taught the shape of the codebase. A test taught what the product was supposed to do. A bad pull request taught how the team made decisions. A production incident taught fear, responsibility, and caution. The company paid for slow work today in order to create a capable engineer tomorrow. That bargain built the software industry. Now the bottom step is disappearing. The threat is not that artificial intelligence can write one line of code. That happened years ago. The threat is that coding agents can take an entire ticket, read the repository, find the relevant files, make changes, run tests, fix errors, open a pull request, respond to review comments, work in the background while a senior engineer does something else. GitHub calls its coding agent an autonomous background agent. OpenAI describes Codex as a system that can complete features, refactors, migration, reviews, and other engineering work end-to-end. Anthropic says Claude Code can read a codebase, edit, run commands, execute tests, and deliver committed code. These products are not only fast autocompile, they are beginning to look like junior developers who never need sleep, never ask for a salary, and can be started from a task description. They are not equal to a great human engineer. They do not need to be. To damage the junior career ladder, they only need to become good enough at the work companies once used to train beginners. That is the real story. The AI coding revolution may not eliminate software engineering. It may remove the apprenticeship system that creates software engineers. The difference matters. A profession can continue growing while the entrance becomes narrower. The United States Bureau of Labor Statistics still projects strong growth for software developers over the next decade. Software is spreading into vehicles, healthcare, robotics, enhanced manufacturing, security, energy, and almost every product. The world may need more software than ever. The world may not need the same number of people writing routine code. Those statements can both be true. Demand for finished software can rise. Demand for beginner labor can fall. A company may produce more applications with fewer entry-level developers. Senior engineers may supervise fleets of agents. One product manager may create a prototype that once required a small team. A founder may delay hiring. A consulting company may complete a project with half the staff. The industry expands. The doorway contracts. This is why the usual debate about whether AI will replace programmers misses the most important point. Jobs are not removed evenly. Technology rarely deletes an occupation in one clean motion. It changes the shape of the work. The easiest pieces move first. The most standardized tasks. The tasks with clear instructions. The work that can be checked automatically. The work with low consequences when it fails. Those are exactly the tasks given to junior. A senior engineer is not valuable because the senior types faster. The senior understands the system, knows which requirements are wrong, recognizes hidden risk, can argue with the product manager, can choose what not to build, understands why a strange piece of code exists, remembers the outage from 3 years ago, sees when a simple request will damage 5 other services. AI coding agents are weakest around this invisible knowledge. They are strongest where the task is narrow and the test is clear. Add a field. Create an endpoint. Write unit tests. Update dependencies. Refactor a module. Convert a file. Generate boilerplate. Explain an unfamiliar function. Prepare a first draft of a pull request. This is junior territory. The result is an economic temptation no engineering manager can ignore. Imagine a team with 5 senior developers and 5 juniors. The juniors cost less. They also require attention. They need onboarding, code review, explanation, correction, meetings, mentoring. The seniors lose time teaching. The company accepts this because the juniors become productive later. Now give the 5 senior developers powerful coding agents. Each senior can delegate routine tasks. The agents work in parallel. The seniors review output. Management asks a brutal question. Why hire 5 juniors? Why not hire 1? Or none? The company can spend money on agent subscriptions and keep the experienced engineers who know the product. The immediate spreadsheet looks better. More output. Lower payroll. Less management. No recruiting cycle. No benefits. No fear that the junior will leave after training. The long-term cost is hidden. The team stops creating future seniors. This is talent debt. Technology companies understand technical debt. They shortcut makes development faster today and slower later. The code base becomes harder to change. The organization may now create talent debt in the same way. It removes beginner roles to save money. Years later, it discovers there are not enough experienced engineers. The senior employees retire, leave, or become managers. The agents generate code. Nobody understands the whole system. The company has productivity. It does not have judgment. The junior career ladder was inefficient. It was also a knowledge production system. The industry may destroy it before building a replacement. To understand how serious this is, look at what junior developers actually do. The stereotype is simple. A junior writes basic code. A senior writes advanced code. Real teams do not work that cleanly. A junior often handles the edges around engineering, documentation, small bug reports, simple tests, internal tools, configuration, data cleanup, customer-specific changes, basic dashboard, migration scripts, support tickets, code searches, dependency updates, repetitive front-end work. The junior asks the questions experienced people no longer think to ask. Why does this function exist? Why do we use this database? Why is this service separate? Why can we not change the APIs? The questions can be annoying. They expose assumptions. The junior becomes a fresh pair of eyes. AI agents are very good at producing the first draft of much of this work. They can search thousands of files faster than a new employee. They can summarize architecture. They can generate documentation. They can create tests. They can translate code between languages. They can follow patterns already present in a repository. They can make a small change without needing 3 weeks of orientation. This is powerful. It is also dangerous for the entry level. A new graduate once competed with other new graduates. Now the graduate competes with an experienced engineer using several agents. The comparison is unfair. The senior knows what to ask. The agents apply speed. The combination is stronger than either alone. This is the new unit of competition. Not human versus AI. Human with AI versus human without experience. The senior engineer receives a productivity multiplier. The junior receives a credibility problem. A company looking at the candidates may think this way. Candidate A has 10 years of experience and can supervise coding agent. Candidate B has no production experience and also uses coding agent. Both can generate code quickly. Only one knows whether the code should exist. The tool that was supposed to democratize programming may increase the value of expertise. Anthropic studied this effect in Claude code usage and found persistent returns to expertise. As Agent IC coding expanded, experienced users did not become less important. They used the system for broader work. They moved beyond fixing code into operating software. Analysis and surrounding tasks. The agent did not erase expertise. It gave expertise a larger surface area. This is excellent for senior developers. That can be terrible for people trying to become senior. The old career ladder was built on scarcity. A company needed humans to complete every small task. The junior received practice because somebody had to do the work. AI changes the incentive. The agent does not need practice. It arrives with broad knowledge. The company can choose efficiency over education. No law requires a software team to train beginners. The market created that behavior because it needed labor. When the need changes, the training can vanish. This has happened in other industries. Automation removed entry-level clerical work. Young people lost the jobs that once taught how an office operated. Self-service systems removed routine bank work. Digital publishing reduced production roles that once led toward design careers. Manufacturing automation removed simple shop floor tasks that introduced workers to industrial systems. The advanced jobs remained. The path toward them became less obvious. Software developers once believed they were protected because they created automation. Now automation is entering the process that creates automation. The irony is perfect. The people who replaced routine work elsewhere are watching routine work disappear inside their own profession. The first stage was autocomplete. A developer typed a comment. The tool suggested code. This increased typing speed. The human still directed every step. The second stage was chat. The developer asked for an explanation, function, test, or debugging help. A model became an advisor. The third stage was agent mode. The tool could inspect files, make candidates, run commands, and recover from errors. This human provided a goal. The system handled more of the path. The fourth stage is asynchronous coding. The developer assigns several tasks. The agents work in separate environments. They return pull requests. The human reviews. The role begins to resemble management. The fifth stage is multi-agent engineering. One agent plans. Another implements. Another tests. Another reviews. Another monitors production. The human chooses priorities and approves risk. The distance between intention and code grows. Each stage removes more of the work that trained juniors. Autocomplete removed memory work. Chat removed many basic questions. Agent mode removed first drafts. Asynchronous agents removed ticket ownership. Multi-agent systems may remove entire categories of implementation. The junior no longer gets the assignment. The senior delegates it to software. This is not science fiction. GitHub's coding agent can work in a separate development environment, compile code, run tests, and use repository instructions. Codex can work on multiple tasks in parallel inside clouds and boxes. Cloud code can operate through terminals, development environments, browsers, and automated workflows. These systems still make mistakes. Their organizational effect begins before perfection. A company does not wait for an agent to replace 100% of a job. If the agent handles 30% of junior work, the company may hire 30% fewer juniors. If it handles 60%, the intake class shrinks again. The career ladder can collapse through small hiring decisions across thousands of companies. No executive announces the end of junior developer. One manager leaves a position unfilled. Another replaces an internship with an agent pilot. A startup waits another 6 months before hiring. A consulting firm assigns fewer graduates to a project. A senior engineer closes a backlog using Claude code over a weekend. A product team ships without expanding headcount. The numbers change quietly. By the time the industry notices, the entry-level market is already crowded. This is why graduate job seekers can feel a crisis even while official employment forecasts remain positive. Occupational statistics describe the whole profession. They do not guarantee a smooth first step. The number of experienced positions can grow. The number of beginner positions can shrink. Average salaries can stay high. New graduates can struggle. Both sets of data can be correct. The title of computer programmer is already projected to decline in the United States, with automation of repetitive programming tasks listed as one factor. Software developer roles are projected to grow because the work includes broader design, analysis, and system responsibility. The distinction reveals the future. Typing code is pressured. Owning software remains valuable. A junior career built around typing tickets is vulnerable. A junior career built around understanding users, systems, testing, security, and deployment may survive. The profession is moving upward. The problem is that beginners cannot begin at the top. A company asks for system judgment. Judgment comes from experience. Experience used to come from small coding tasks. The agent takes the small tasks. The graduate faces a circular demand. You need experience to supervise AI. You need a job to get experience. The job wants someone who can supervise AI. This is the broken ladder. Universities can teach theory. Boot camps can teach frameworks. Online courses can teach syntax. None of them fully reproduce production responsibility. A student project does not contain a decade of legacy decision. The tutorial does not wake you during an outage. A coding challenge does not include a confused customer. A clean repository does not teach how to work inside a system nobody fully understands. The difference between a student and a professional is not knowing more programming language feature. It is learning what happens when code meets an organization. The junior job was the bridge. If the bridge closes, education must change. Before discussing the replacement, we need to understand why companies will still be tempted to close it. The basic economic model is compelling. A junior developer costs salary, benefits, equipment, recruitment, and senior attention. The junior may take months to become productive. The junior creates code review work. The junior can make production mistakes. A coding agent costs a subscription or usage fee. It can begin immediately. It can work overnight. It can create several versions. It does not become embarrassed by feedback. It does not leave for a competitor after 12 months. From the perspective of a quarterly budget, the agent wins. The agent also makes senior employees happier when it removes boring work. Nobody enjoys updating hundreds of test snapshots. Nobody dreams of migrating configuration files. Nobody wants to write the same API wrapper again. The tool can free experts for architecture, product decision, and difficult debugging. That is real value. The company can improve both speed and satisfaction. The negative effect on juniors is not the intention. It is the side effect. This makes the problem harder to stop. There is no villain required. A manager makes a rational local decision. The industry creates an irrational global outcome. Every company wants to hire experienced engineers. The few companies want to create them. This is similar to companies demanding trained workers while cutting training budgets. The difference is that software once created training automatically through normal work. AI separates production from learning. The task can be completed without teaching a person. Production becomes efficient. Human capital becomes somebody else's problem. This is a classic market. The company that trains a junior pays the cost. Another company can hire that person later. The company using agents avoids the cost and benefits from senior talent trained elsewhere. As more companies behave this way, the supply of seniors falls. The industry may respond with higher salaries. That makes agents even more attractive. The cycle reinforces itself. Fewer juniors, scarcer seniors, more expensive expertise, more agent invest, higher leverage for the remaining expert. The software team becomes an inverted pyramid. A small number of highly experienced engineers at the top, a large layer of agents below, very few humans entering at the bottom. The organization can produce enormous amounts of code. It becomes fragile in a different way. The experts are bottlenecks. Every important decision waits for them. Every agent output requires judgment. Every incident escalates upward. The company saved money on juniors and created dependency on a handful of people. This is not only a labor issue. It is an operational risk. If one senior leaves, the team loses context. The code remains. The agents can explain parts of it. They may not know where the company made historical compromises. The organization begins to confuse documented code with institutional memory. They are not the same. A repository tells you what exists. It does not always tell you why. The reason may live in an old meeting, a customer promise, a legal settlement, a failed experiment, a relationship between departments. Humans carry this context. Junior developers absorb it over time. They become continuity. If companies stop renewing the human layer, they create a memory problem. The agents may become better at reading histories. They can search tickets, messages, commits, and documents. This reduces the risk. It does not remove it. Documents are incomplete. Important decisions are often unwritten. Organizations say they want to document everything. They rarely do. The senior engineer knows which document is wrong. The model may treat it as truth. This is why expertise remains valuable. The question is who gets the opportunity to develop it. The productivity evidence is already more complicated than marketing suggests. GitHub has reported large gains in controlled studies and user surveys for some coding tasks. Developers often feel faster. Coding agents can complete work that once took hours. Other research found surprising results. A randomized study by an EDR examined experienced open-source developers working on mature repositories they knew well. Using early RDR way, tools made the developers 19% slower in that specific setting, even though they believed the tools made them faster. A later update using newer tools found evidence pointing toward improvement, but with substantial uncertainty. This does not prove AI coding tools are useless. It proves productivity is not one number. A model can be fast at generating code and slow at understanding a mature system. The developer spends time prompting, waiting, reviewing, correcting, cleaning. The tool creates code faster than the team can trust it. For a simple task, I wins. For a complex task inside an unfamiliar architecture, the human may lose time. For an expert who already knows the code base, the tool can interrupt thought. For a junior who does not know where to start, the tool can be transformative. The same technology affects people differently. This creates a strange possibility. AI may help juniors perform tasks sooner. Companies may still hire fewer juniors. The tool increases individual capability and reduces aggregate demand. A graduate can build more. The market needs fewer graduates to build the same amount. This is the productivity paradox in labor markets. Workers become more productive. Employment does not automatically rise. The price of the output can fall. Demand can expand. New products can appear. Whether jobs grow depends on which effect is stronger. Software has historically experienced strong demand expansion. Better tools made development cheaper. Cheaper development created more software. More software created more developer jobs. Compilers did not destroy programming. High-level languages did not destroy programming. Open-source libraries did not destroy programming. Cloud computing did not destroy programming. Each removed work and expanded possibilities. Optimists argue coding agents will do the same. They may be right about total demand. The junior ladder can still be damaged. Previous tools usually removed low-level machine work while creating new human work at a higher level. Developers learn it on the new tools. Coding agents are different because they can perform the new higher-level work too. A library replaces writing one algorithm. An agent can choose the library, integrate it, test it, and explain the result. The abstraction keeps rising. The human moves from implementation to specification, then from specification to product judgment. The ladder is moving upward faster than education can follow. A beginner may build a complete application with AI. That does not mean the beginner understands the application. The product can work until it does not. When the system fails, the knowledge gap appears. This is the central danger for AI native junior. They can produce professional-looking output before developing professional judgment. The code creates an illusion of competence. The person asks the agent for architecture. The agent produces clean folders, tests, and documentation. The project looks mature. A security flaw hides inside authentication. A database design fails under real load. A dependency creates licensing risk. The junior cannot see the weakness. The tool has raised output faster than understanding. This problem existed with copying code from the internet. AI makes it continuous and personalized. The junior is not cheating. The junior is using the standard tool. The learning process changes. When a person struggles with a bug for hours, the struggle creates a mental model. When the agent fixes it in seconds, the result arrives without the model. Time is saved. Learning may be lost. Not every struggle is valuable. Nobody needs to suffer through problems already solved. The difficult question is which friction creates expertise. If AI removes all friction, it may remove the training signal. A junior developer can become dependent before becoming capable. The person learns to ask for code, not to reason about code. This is why Agent IC coding could create a generation of developers who can produce systems but cannot own them. The best juniors will use AI differently. They will ask why, inspect changes, run tests. This point matters again here because the context has changed. Read documentation, challenge design, break the output deliberately. Use the agent as a tutor and adversary. The weakest will accept the pull request. The gap between them will widen. AI does not only change productivity, it amplifies learning habits. A curious person gains access to an extraordinary teacher. A passive person gains access to an extraordinary crutch. Companies will struggle to tell the difference during hiring. Every candidate can produce polished projects. Meow, me, meow. Every portfolio looks ambitious. The old signals lose value. A take-home assignment can be completed by an agent. A coding test can measure to use more than understanding. A GitHub history can contain generated contribution. Recruiters need new ways to evaluate. Live system design, debugging unfamiliar code, explaining trade-offs, reviewing an agent-generated pull request, identifying security issues, working through ambiguity. The hiring process will shift from creation to judgment. This again favors experience. The junior has less evidence of judgment because the junior has had fewer consequences. The entrance becomes harder. Companies may respond by making internships more important. An internship lets the company observe how a person works with AI. Does the intern verify? Ask good questions. Learn, communicate, understand users. The internship becomes the new addition. If companies reduce internships because agents do intern work, the contradiction deepens. The most important training program is the first thing automation threatens. This is how a career ladder disappears. Not because the profession is dead, because the first rung is no longer profitable. The first companies to feel the change may not be giant technology. They may be small startups. They start up lives under pressure. Limited cash, limited time, a product that may fail. Every hire matters. In the old model, a founder hired a junior developer because the company needed more hands. The junior built features, fixed bugs, and grew with the business. In the new model, the founder can use coding agents personally. A technical founder can produce a prototype alone. A senior engineer can maintain a product with agents. A designer can generate front-end code. A product manager can create an internal tool. The startup delays its first engineering hire. When it finally hires, it wants someone experienced enough to own a large area immediately. The role that once launched a career never appeared. This is happening through absence. There is no layoff announcement for a job that was never created. The economic data will lag because lost opportunities are difficult to count. We see employees. We do not see the junior position a company considered and then replaced with software. This invisible substitution is likely to be one of the defining features of the AI labor market. Large companies move differently. They have graduate programs, university relationships, and long-term workforce plans. They also have cost pressure. An executive sees thousands of developers and asks how many are necessary after AI. The answer may not be immediate layoffs. The company can slow hiring, reduce campus recruiting, cancel contractors, leave positions empty after employees leave. Expect more output from each team. The workforce shrinks through attrition. Junior employees feel the effect first because they have the least bargaining power. The company protects architects, security experts, platform engineers, and people with product knowledge. It reduces roles that can be standardized. Graduate hiring becomes a variable cost. The career ladder narrows again. Consulting and outsourcing companies face an even deeper challenge. Their traditional business model often depends on leverage. A smaller number of senior people manage a larger number of junior employees. The client pays for the team. The consulting company hires graduates, trains them, and bills their time. Junior labor is not only a cost, it is inventory. How coding agents attack this structure. If one senior consultant with agents can deliver the work of several juniors, the project needs fewer billable people. The client asks why it should pay for a large team. The consulting firm can resist. The client knows the tools exist. Billing by hours becomes harder when software performs more of the hours. The company must move toward pricing outcomes. A migration completed. A platform modernized. A system deployed. This can create higher margins if the firm uses AI well. It removes the economic reason to hire large graduate classes. The old pyramid becomes a diamond. Senior experts, a smaller middle layer. A narrow junior base. Coding agents under everyone. The consulting industry has been one of the world's largest training systems for technology workers. It absorbs graduates, places them on projects, exposes them to clients, teaches enterprise systems. If that intake falls, the effects spread far beyond consulting. Banks, retailers, manufacturers, and governments often hire people trained by service companies. The whole talent ecosystem depends on somebody paying for the first. AI can break that chain. Offshore software development faces similar pressure. For decades, companies moved routine development work to lower-cost markets. Large teams handled maintenance, testing, support, data work, and application development. A model depended on wage differences. Coding agents reduce the value of cheap routine labor. A company compares to option, a large offshore team, or a smaller experienced team with agents. The second option may communicate more easily and require less coordination. This can pressure technology employment in countries that built large service economies. The impact will not be uniform. Offshore firms can adopt agents too. They can lower prices, deliver faster, use local talent to supervise tools. The strongest firms will move into architecture, industry expertise, cybersecurity, cloud transformation, and AI implementation. The lowest value work faces pressure. This is the same latter problem at national scale. Countries used routine software work to train millions of people. Those people moved into management, product, architecture, and entrepreneurship. If the routine layer disappears, economic development paths change. AI coding agents can redistribute opportunity toward people who already have experience, capital, customers, and language access. Agile available to everyone can still increase inequality. Access is equal. Leverage is not. The senior engineer knows which task to delegate. The junior does not know what the task. The startup founder owns the product. The outsourced worker receives instruction. The company with proprietary data can build valuable systems. The student has a generic model. Technology amplifies position. This is why the phrase democratizing coding needs careful examination. It makes the act of creating software more accessible. A person without formal training can build an application. That is real democratization. I can make the professional labor market more selective at the same time. More people can code. Fewer companies need to pay beginners to code. The supply of apparent developers explodes. The demand for basic implementation falls. The market value of code generation declines. The value of product judgment, distribution, ownership, and expertise rises. This is a familiar economic pattern. When a skill becomes abundant, the scarce complements become valuable. Lithography became easier. Attention and brand remained scarce. Publishing became easier. Audience remained scarce. Creating websites became easier. Customer acquisition remained scarce. Coding becomes easier. Knowing what to build and operating it safely remains scarce. The junior developer career was built around code as a scarce skill. The next career must be built around ownership. This changes what education should teach. Computer science programs traditionally combine theory and programming, algorithms, data structure, operating systems, networks, databases, software engineering. Students complete assignments that test whether they can implement an idea. AI can complete many assignments. Schools can ban the tools. Enforcement will be difficult. The workplace will use them. Banning them can train students for a world that no longer exists. Allowing them without redesign can destroy learning. A student asks the agent to write the project. The project passes. The student learns prompt pattern. The degree loses meaning. Education must move from output to understanding. A student should explain the system, review a flawed implementation, measure performance, threat model the design, respond to changing requirements, debug under observation, work in teams, operate software over time. Use say-I and document the decision. The assignment becomes a process, not a file. This is more difficult to teach and grade. It is closer to work. Universities may need production-like environment. Long-lived code bases shared across semesters. Real users. Incidents. Maintenance. Students inherit code from previous classes. They experience technical debt. An AI agent can help. The student remains responsible. This can rebuild part of the apprenticeship inside education. The degree becomes more expensive to deliver. Large lecture courses are easier than mentored engineering work. Institutions may not adapt quickly. Boot camps face a stronger threat. Many boot camps sold a short path into entry-level web development. Learn a framework, build projects, pass interviews, get a junior job. Coding agents attack every part of that commerce. They can teach syntax, generate portfolio projects, prepare interview answers, perform common front-end work. Employers raise expectations. A few months of framework training no longer differentiates a candidate. Boot camps must evolve into AI native apprenticeships. Real system, client work, code review. This point matters again here because the context has changed. Deployment, security, product thinking. The easy promise disappears. This can be healthy for education. It is painful for people who believe software was a reliable route into the middle class. The old career ladder was not fair. It was one of the better ladders available. A motivated person could learn online. Build projects. This point matters again here because the context has changed. Enter a junior role. Grow quickly. The path did not require family connections in every case. It did not require years of unpaid professional work. AI may lower the cost of building software while raising the cost of proving you deserve a job. The person can create a product alone. That may become the new portfolio. Do not show a to-do application. Find a real problem. Acquire users. Operate the product. Handle support. Fix incidents. Explain decision. The candidate proves ownership rather than syntax. This is a higher bar. It can reward initiative. It can punish people without free time, money, networks, or confidence. The latter moves from employment toward entrepreneurship. Not everyone can take that risk. Another route may be open source contribution. A beginner joins a real project, reviews issues, works with maintainers, uses agents transparently, builds a public history of judgment and collaboration. This resembles the old junior job. The community provides mentorship. The person receives experience. The work may be unpaid. Open source cannot become the entire industry's free training department. Maintainers are already overloaded. AI-generated low-quality contributions can increase the burden. A beginner using an agent can create 10 pull requests. A maintainer must review them. The output is cheap. Attention is expensive. This is becoming a central bottleneck in software engineering. Coding agents increase the supply of code. They do not automatically increase the supply of trusted review. The scarce resource moves from writing to verification. Senior engineers become reviewers of machines and humans. Their time becomes more valuable. The junior can contribute by becoming excellent at verification, testing, security analysis, reproduction, observability, quality assurance. But traditional QA roles are also exposed to automation. Agents can generate tests, run them, analyze failures. The human must focus on what the tests miss. User behavior, adversarial cases, business consequences. The work becomes more conceptual. Again, the entry bar rises. One promising new junior role is the AI native product engineer. This person is not hired for typing speed. The person can move from idea to working system using agents, APIs, databases, and cloud services, understands enough code to verify output, talks to users, measures results, owns deployment. A small team of these engineers can build quickly. The role can create a new ladder. The problem is training. How does a beginner learn to verify architecture before seeing architecture fail? The company must design structured responsibility. Give the junior a bounded system. Let the agent assist. Require the human to explain, test, monitor, and improve it. The apprentice learns through ownership, not manual typing. This may be the replacement model. Old apprenticeship. Write the code. Receive feedback. New apprenticeship. Direct the agent. Review the code. Defend the design. Operate the result. Receive feedback. This point matters again here because the context has changed. The human still needs repetition. The repetition moves upward. Companies can preserve talent development if they treat agent supervision as a learnable skill. A junior can begin with low-risk workflow. The agent proposes changes. The junior reviews. A senior reviews both. The junior explains what the agent did and why. Over time, responsibility expands. This is slower than giving every task directly to the senior. It is an investment. The old ladder was also an investment. The difference is that management must now choose it deliberately. Before AI, training happened because juniors produced necessary work. After AI, training must be designed. This is the central organizational challenge. Companies that solve it can gain an advantage. Everyone else may compete for a shrinking pool of senior talent. A company with a strong AI apprenticeship program can create engineers adapted to its systems. The junior learns company context and agent use at the same time. The company receives loyalty in a pipeline. The training costs can be lower because agents support the apprentice. The model does not have to destroy the ladder. It can become part of a better ladder. The market may not do this automatically. Leaders need long-term thinking. Many technology companies are managed through short-term headcount targets. The executive who reduces junior hiring receives credit today. The executive who lacks senior talent in 5 years may be a different person. Talent debt is easy to create when accountability is delayed. Boards and engineering leaders should measure it. Age and experience distribution, promotion rates, mentoring time, entry-level intake, critical knowledge concentration, succession plans. The organization tracks cloud spending and security vulnerabilities. It should track whether it is still capable of producing experts. This is a business continuity issue. A team made entirely of seniors may look strong. It has no renewal. A team made entirely of agents and seniors can become expensive and rigid. Senior engineers do not remain senior forever. Some move into management. Some burn out. Some retire. Some start companies. The pipeline matters. The industry may respond with new institutions, shared apprenticeships, industry-funded training, public programs, professional certifications based on supervised work. Companies could sponsor rotations. Consultants could sell training alongside implementation. Universities could partner with open source projects. Cloud providers and AI companies could fund developer residencies. The companies selling coding agents benefit. They have incentives to prevent its collapse. GitHub, Microsoft, Anthropic, OpenAI, Google, Amazon, and others may create programs that teach agent IC engineering. Not because of charity. Future customers need skilled users. An agent without competent supervision creates bad software. Bad software damages trust in the tool. The vendors need human expertise to remain available. This is another paradox. Coding agents can reduce junior hiring. Agent companies need future senior developers. They may become training providers for the labor market they disrupted. The training can also become a platform strategy. iCompany certifies developers on its agent. Those developers bring the tool into employers. Education creates distribution. Cloud companies have used certifications this way for years. AI coding certifications may appear. They can't teach workflows. They can also become shallow marketing. A certificate does not replace production experience. The strongest programs must involve real responsibility. Another possibility is that companies stop using the labels junior and senior in the old way. Experience with AI changes the curve. A person with 2 years of intense agent-assisted work may produce more than a traditional mid-level engineer. A person with 10 years of experience who refuses the tools may fall behind. Seniority becomes multi-metanation, system knowledge, product judgment, technical depth, agent orchestration, communication, risk management. The number of years matters less. This can create faster paths for talented newcomers. The ladder may become steeper but shorter. A junior who learns quickly with AI can encounter more code and more scenarios in 1 year. The agent explains unfamiliar systems, generates examples, simulates failures, reviews the person's thinking. The learning rate can increase dramatically. The AI can destroy passive apprenticeship and create active accelerated apprenticeship. The difference depends on use. A junior who delegates every challenge learns slowly. A junior who uses the agent to explore every challenge learns quickly. Companies need to distinguish the two. This requires observing process. A pull request no longer reveals who did the thinking. Managers need conversations, design reviews, post-incident explanations. The junior should be able to reproduce the reasoning. This increases the importance of communication. The stereotype of the programmer alone at a keyboard weakens. The future engineer must explain decisions to humans and machines. A good prompt is a form of specification. A good review is a form of judgment. A good incident report is a form of organizational learning. Writing becomes more important, not less. The agent generates code from language. Vague language creates vague systems. Senior engineers are often strong because they can turn ambiguity into precise decisions. Juniors can train this skill early. Talk to users, write requirements, define tests before implementation, describe failure mode. The agent handles syntax. The person owns meaning. This is a viable career. It is not the career many schools currently teach. The effect on hiring interviews will be dramatic. Leak code style algorithm questions became popular because companies needed scalable filters. Candidates practice patterns. AI can solve many of them. Banning AI in the interview tests memory rather than future work. Allowing AI makes the task too easy unless the interview changes. Companies will evaluate collaboration with agents. Give the candidate a broken system. Allow tools. Watch how the person investigates. Does the candidate accept the first answer? Check logs, read tests, challenge assumptions, use the model effectively, recognize uncertainty. The interview becomes closer to real engineering. This can improve hiring. It can also become more subjective. Subjectivity creates bias. Standardized tests were imperfect but comparable. Agent-assisted work produces varied paths. Companies need structured evaluation criteria. The junior market will be shaped by whoever designs credible signals. Platforms may emerge to verify engineering ability through long-term work samples, simulated production environments, measured debugging, security challenges, team collaboration. AI use logs. The candidate builds a reputation over time. This resembles a game. It can become another barrier. The wealthy candidate pays for premium tools and coaching. The industry must be careful not to replace one flawed filter with a more expensive one. Geography changes too. Remote work expanded the candidate pool. Coding agents expand output. A company can hire fewer people from anywhere. Competition for entry-level roles becomes global. A graduate in one country competes with graduates everywhere, experienced freelancers using agents and automated systems. Wage pressure can increase. At the same time, the talented person anywhere can build a global product with AI. Opportunity shifts from employment to creation. The most entrepreneurial benefit. The most risk-averse suffer. Economic security matters. A person with savings can spend a year building. A person supporting a family needs a salary. The junior career ladder was valuable because it paid people to learn. The new model often asks people to learn by building for free. This is not equal. Policy may eventually enter the conversation. Governments fund apprenticeships in skilled trades because markets underproduce training. Software may need similar support. Tax credits for junior hiring. Public digital service programs. Paid technology apprenticeships. Requirements in government contracts. University-industry partnerships. This sounds strange for a profession once associated with talent shortages and high salaries. The market can change quickly. If software remains economically important and private companies stop training enough people, public investment becomes rational. National security depends on technical talent. Governments cannot rely entirely on coding agents created by private foreign companies. They need people who understand systems. Human capability is strategic infrastructure. The latter is not only a career issue, it is a national capability issue. A country with no junior engineers eventually has no independent senior engineers. It becomes dependent on tools and vendors. This resembles the loss of manufacturing skills. Once the apprenticeship chain breaks, rebuilding it is difficult. Experts cannot be produced instantly. AI can help teach. It cannot supply live responsibility on demand. This is why the junior developer debate matters beyond people looking for their first job. It is about whether society retains the ability to understand the software controlling it. Banks, hospitals, energy systems, defense, transportation, government. If code is produced by agents and supervised by a shrinking elite, technical power concentrates. A small number of people and companies understand the systems. Everyone else becomes a user. The open source movement spread software knowledge broadly. The junior career ladders spread professional knowledge broadly. Coding agents can reverse part of that distribution if only experienced people can use them responsibly. The optimistic future is different. Agents make software knowledge available to more people. A nurse automates a workflow. A scientist builds an analysis tool. A small business creates internal software. A student launches a product. Professional developers focus on infrastructure, safety, and difficult systems. The total number of people building software increases. The title developer becomes less important. Coding becomes a general skill mediated by AI. In this future, the junior developer is not destroyed. The category dissolves into many AI-assisted builders. The professional ladder remains for high-risk engineering. The entrance changes. A person may begin in marketing, operations, science, design, or finance, build tools, develop technical depth, move into engineering. The path becomes less formal. This can expand access. It can also reduce clarity. The old ladder told people what to do. Learn code, to junior job, become senior. The new world offers many paths and no guarantee. Build something. Learn systems. Find a niche. Use agents. Prove judgment. Develop expertise. The advice is less comforting. It may be more accurate. The biggest mistake a new developer can make is competing with the agent at what the agent does best. Boilerplate. Syntax recall. Basic transformation. Routine tests. The human should build strength where agents remain weak. Problem definition. System design. Security thinking. Understanding users. Debugging messy reality. Communication. This point matters again here because the context has changed. Prioritizations. Responsibility. The ability to decide when not to use AI. These skills sound senior. Juniors must start practicing them earlier. The title of junior once meant limited responsibility. The future junior may receive broad responsibility with heavy AI support. This can accelerate, it can create dangerous pressure. A beginner may be asked to own systems beyond their understanding because the agent makes output look easy. Companies must not confuse generated capacity with human readiness. A junior who can produce a feature in one day may still need supervision. The review burden does not disappear. It changes shape. The senior no longer checks every line manually. The senior checks architecture, test, permissions, data flows, and operational risk. Review becomes more important because output volume grows. The team can generate 10 times more code. Can it understand 10 times more code? This is the coming code inflation problem. Software supply becomes cheap. Software complexity can explode. Every department generates internal tools. Every agent submits pull requests. Every customer requests customization. The organization accumulates systems faster than it can maintain them. The junior developer once helped maintain the long tail. If juniors disappear, who owns the generated code? Agents can maintain agent-generated code. This is the promise. The system becomes circular. An agent writes the feature. An agent tests it. An agent monitors it. An agent fixes it. The human oversees the port. This can work for low-risk systems. When something unusual happens, the human faces a code base nobody deeply learned. The company has automation debt. Talent debt meets technical debt. The productivity boom can create an operational hangover. The winners will control code creation. They will also control code deletion. The ability to remove systems, simplify architecture, and refuse unnecessary features becomes valuable. AI naturally generates. Good engineering often subtracts. A senior says no. A junior learns why. If the junior only sees generation, the industry loses the discipline of simplicity. The career ladder should teach restraint. The agent should not become a ticket machine producing every request. Teams need product and architectural judgment. This strengthens the case for fewer, more capable engineers. It also strengthens the case for deliberate apprenticeship. The junior must learn not only how to create, how to choose. This is the real future skill. The most likely future is not a world with no junior developers. It is a world with fewer traditional junior roles and much higher expectations for the people who receive them. The bottom of the ladder becomes selective. Companies may hire smaller classes, provide better tools, give broader responsibility, promote faster. The junior becomes more like an apprentice pilot in an automated cockpit. The system handles routine control. The apprentice must understand the whole aircraft. This changes the economics of training. A company can hire one junior and give that person the output capacity once associated with several people. The firm can afford to invest more in that person's education. Mentoring can become deeper. The junior can work on meaningful tasks sooner. The best case is not fewer people abandoned at the door. It is fewer people per team receiving better apprenticeship. The worst case is fewer people receiving no apprenticeship at all. Which future wins depends on management. A thoughtful engineering organization will separate production capacity from talent development. It will not ask whether a junior is needed to finish the sprint. It will ask whether the company needs future engineering leadership. That is a different budget discussion. The junior role becomes a strategic investment. The company may protect it the way it protects research. The immediate return is uncertain. The long-term option is valuable. Some organizations will do this. Others will free ride. The market may split. Elite companies with strong brands and large budgets run serious graduate programs. They attract the best candidates. Smaller companies stop hiring beginners. The career ladder becomes concentrated inside a few institutions. This can increase inequality within the profession. A person who enters a top program receives mentoring, agents, real systems, and powerful networks. A person who misses the entrance struggles to acquire equivalent experience. The first job becomes more important than ever. This is already true in many professions. I can make it extreme. Large technology firms may become the universities of software engineering. They train a small number of people who later spread through the market. If those firms reduce entry-level intake to far, the whole industry suffers. The companies selling coding agents have an opportunity to build a different ecosystem. Imagine an agent designed not only to complete work, but to teach. It asks the junior to predict the change before generating it, explains the architecture, creates a broken example, tests understanding, refuses to hide important decisions, keeps a learning record, escalates when the user accepts code without review. The product measures skill growth, not only output. Most coding agents are optimized for completion. The enterprise pays for work done. An educational agent would optimize for human capability. This can become a market. Companies need evidence that employees are learning rather than becoming dependent. A training mode can help. A manager can see whether the junior understands tests, security, and system behavior. The tool becomes a mentor. It will not replace a human mentor completely. It can make one mentor capable of supporting more people. This is how A could repair the latter it threatened. The same coding agent that removes routine tasks can create simulations of routine tasks. The junior can practice in a safe environment, replay incidents, review historical bugs, explore alternative designs, work through production like scenarios without harming customers. A company has years of past pull requests and outages. AI can turn that history into a curriculum. Why did this incident happen? What would you change? Which test was missing? Which assumption failed? The junior receives concentrated experience, not identical to real responsibility. Better than passive observation. The apprenticeship becomes partly synthetic. This is similar to flight training. Pilots do not learn every failure in a real aircraft. They use simulators. Software engineering has rarely had serious simulation because creating realistic scenarios was expensive. AI can generate them. This may be one of the most positive uses of coding agents, not replacing the beginner, increasing the number of experiences the beginner can safely have. The industry must choose to build for this outcome. The current market rewards task completion. Education may require separate incentives. Insurance and regulation could create them. A company deploying high-risk AI-generated code may need evidence of human competence. Certification bodies may require trained reviewers. Security standards may demand named owners. Auditors may ask who understood the change. The human capability layer becomes part of compliance. This can protect apprenticeship in critical sectors. A bank cannot say the agent wrote the code. A responsible person must approve it. A hospital cannot delegate accountability to a model. An aircraft system needs qualified engineers. The higher the consequence, the stronger the human ladder remains. This means junior opportunities may move toward regulated and complex domains. Healthcare software, financial infrastructure, cybersecurity, industrial systems, energy, defense. This point matters again here because the context has changed. These fields cannot simply accept generated code. They need verification. The learning curve is harder. The career can be more durable. Simple consumer applications face greater automation. The junior web developer building standard interfaces is more exposed than the junior security engineer investigating strange behavior. This does not mean everyone should move into cybersecurity. It shows where human judgment retains value. The market will price consequence. A low-risk landing page can be generated. A payment system demands responsibility. New developers should seek environments where the code matters enough to require understanding. This sounds counterintuitive. Harder fields may provide safer careers. The same principle applies to domain knowledge. A developer who understands logistics, healthcare, finance, manufacturing, or scientific research brings more than code. The agent knows general patterns. The human understands the actual operation. Domain expertise becomes a moat. A junior can start building it immediately. Talk to users. This point matters again here because the context has changed. Learn the regulations. Understand the metrics. Visit the facility. Follow the workflow. The person becomes difficult to replace because the role connects software to reality. AI coding agents are strongest in the repository. The business exists outside the repository. The engineer who crosses that boundary remains valuable. Product sense becomes another protective skill. The agent can build what is specified. Companies often specify the wrong thing. A junior trained only to implement tickets is vulnerable. A junior trained to discover user problems is stronger. Why does the customer need this? What behavior should change? How will success be measured? Can the problem be solved without software? Which edge case matters commercially? These questions move the person upward. The best engineers have always asked. The difference is that newcomers can no longer wait 10 years to begin. Security thinking is equally important. Agents generate code from patterns. Patterns can contain vulnerabilities. The tool may choose an outdated package, expose a secret, write an unsafe query, create an authorization gap. The junior who can threat model A output provides value. Security is not only a specialized department. Every AI-assisted developer needs adversarial habits. What can go wrong? Who can abuse this? What data is exposed? What happens when the model is wrong? The agent is optimistic. The engineer should be suspicious. This mindset creates trust. Operations may become the greatest teacher. Deploying software reveals reality. Logs, errors, latency, failure, cost. Users. A junior who only generates code remains shallow. A junior who runs the system learns quickly. Companies should give beginners ownership of low-risk production services. On-call support with supervision. Dashboards, incident reviews, cost monitoring. The work creates judgment. Agents can assist. The human experiences consequences. This is the new apprenticeship loop. Build with AI. Operate with humans. Learn from reality. The company can automate code without automating accountability. Another durable skill is code review. Review was once a senior task. Juniors can learn it earlier by examining agent output. The agent produces a change. The junior must explain every important choice. Find one flaw. Improve the test. Compare an alternative. This turns abundant generated code into training material. There will be no shortage of examples. The team can create a review ladder. Begin with obvious issues, move toward performance, security, and architecture. The junior becomes a critic before becoming a master creator. This resembles education in writing. Students read and analyze before producing great work. Software education focused heavily on construction because code was expensive. When code becomes cheap, criticism becomes central. The future developer may spend less time writing from nothing and more time curating, validating, combining, and deleting. This is not a lesser profession. Editors matter even when writers exist. Architects matter even when builders are fast. The danger is that companies call this supervision and assume anyone can do it. Good review requires knowledge. A person cannot validate what they do not understand. The human must remain capable of writing and debugging without assistance in important areas. Not because manual coding is the final job, because understanding cannot be entirely outsourced. Pilots use automation and still train for manual control. Engineers should do the same. AI-free exercises may remain valuable inside education and hiring, not to preserve nostalgia, to test whether the person has a mental model. The goal is not to memorize syntax. It is to reason without accepting a machine's framing. The junior should be able to sketch the system, trace data, and predict failure. Then use the agent to move faster. This creates resilient capability. The career ladder may split into two tracks. The first is the operator track. People use coding agents to build internal tools and simple applications within other roles. They are not traditional developers. They need product and data literacy. The second is the engineering track. People build and maintain complex, high-consequence systems. They need deep technical knowledge and agent supervision skills. The middle layer of routine application coding becomes compressed. This is similar to other technologies. Spreadsheets allowed millions of workers to perform calculations. Professional statisticians and financial engineers still existed. Basic calculation work changed. Website builders allowed millions to publish. Professional software engineering remained. Coding agents expand the operator population dramatically. The title developer may become broader and less meaningful. The professional engineer may need stronger standards. Licensing is unlikely for all software. High-risk domains may move toward formal accountability. The industry has resisted professionalization because it moved quickly. AI-generated code can increase pressure for clear responsibility. Who approved this system? Who tested it? Who owns the risk? The answer cannot be the model. This can strengthen the value of qualified engineers. It can also create barriers for newcomers. Professional pathways need accessible apprenticeships. Otherwise, the field becomes a closed guild. The business consequences extend to software pricing. If agents make development cheaper, companies can build custom software instead of buying SaaS. An enterprise can ask a small internal team to create a tailored tool. This increases demand for engineers who understand the business. It reduces demand for large teams implementing generic features. Software vendors face faster competition. Startups launch more easily. The total amount of code explodes. This can create more opportunities for juniors and new companies. The startups may not hire them. As products grow, operations become complex. They need people. The question is whether founders use the new revenue to expand teams or continue stretching a tiny senior staff. Markets can surprise. Cheaper software creation may unlock millions of projects previously uneconomic. Local businesses, nonprofits, schools, scientists, government departments. They can build tools. Some projects become companies. New employment appears. The job title may be implementation specialist, AI solutions engineer, workflow designer, or product engineer rather than junior developer. The latter does not disappear. It moves sideways. People entering the field should search for the work, not only the title. A role connecting customers to technical systems can teach more than a narrow coding position. Solutions engineering, technical support, developer relations, quality engineering, data operations, implementation, cybersecurity analysis, cloud operations. These roles can become roots into deeper engineering. AI affects them too. The durable path is responsibility around real systems. The candidate should ask one question: will this role expose me to consequences? If yes, learning is possible. If the role only asks the person to accept agent output, growth may stall. The company should ask a related question: will this employee become more capable each year? If not, the company is building dependency. The junior career ladder was never only a set of titles. It was a sequence of increasing responsibility. That sequence can survive. The tasks inside it must change. Year 1 might focus on reviewing agent changes, tests, small services, and incident analysis. Year 2 might include ownership of a production area and coordination of several agents. Year 3 might include system design and mentoring newer employees. The progression can be faster. The company must define it. Without a clear path, juniors become prompt operators. They produce work but do not accumulate authority. This is a dead-end role. The market may create many of them. Low-paid people supervise A output, correct formatting, escalate failures. The agents handle most creation. The worker gains little understanding. This resembles content moderation and data labeling. Human labor remains hidden behind automation. Coding can develop a similar layer. Remote workers clean agent-generated pull requests, fix simple failures, receive low wages because the company believes the AI did the important work. This is another possible future. The junior developer does not disappear. The role is downgraded. Less autonomy, less pay, less training. The career ladder becomes a treadmill. People perform exception handling without learning system design. Companies should avoid this because it creates low-quality software and high turnover. The labor market may produce it anyway. The history of automation includes many jobs where humans serve machines. Warehouse workers follow algorithmic instructions. Drivers respond to platform demand. Content moderators clean automated systems. AI coding and create code janitors. The title may sound technical. The work may be fragmented. This is not the future promised by AI productivity marketing. It is economically plausible. Worker power and job design will matter. Developers may organize around standards for AI, transparency and evaluation, credit for work, training rights, protection against impossible productivity quotas. The profession has historically had high bargaining power through scarcity. If coding becomes abundant, that power can fall at the bottom. Senior experts retain leverage. Juniors do not. The inequality inside engineering can widen. A small group of architects and AI native technical leaders earns extraordinary salaries. A larger group competes for supervised agent work. The middle shrinks. This is the superstar economy applied to software. One senior with agents produces the output of a team. The owner captures savings. The senior may capture some. The displaced juniors capture none. Whether productivity gains create shorter work weeks, higher wages, cheaper software, or larger profits is a distribution question. Technology does not decide. Companies and labor markets decide. The business case for coding agents is strong. The social case needs design. Executives should resist one seductive metric. Lines of code. Agents can generate enormous amounts. More code is not more value. Tickets closed. Pull requests created. Features shipped. These can also mislead. The teams may create maintenance burden. The correct metrics are outcomes, user satisfaction, reliability, security. This point matters again here because the context has changed. Revenue, cost. This point matters again here because the context has changed. Time to recovery, developer learning. The last metric is rarely measured. It may determine the future. An organization using AI should track skill growth. Can employees explain systems better? Can more people handle incidents? Is critical knowledge spreading? Are juniors progressing? In output rises and human capability falls. The company is consuming its future. This is talent extraction. The system pulls value from existing expertise without replenishing it. The company can operate this way for years. The damage appears suddenly when experts leave. The same dynamic can affect the whole economy. Today's agents were trained partly on code created by generations of developers. Future improvement may depend on new high-quality software and human feedback. If fewer people learn deeply, the supply of expert-created code and judgment can weaken. AI can become dependent on a profession it is hollowing out. The model can generate variations of existing patterns. New paradigms require human research, experimentation, and understanding. The frontier still needs experts. Experts need beginnings. This is the recursive problem. Destroy the latter and eventually weaken the source of innovation. AI companies should care for this reason alone. The best possible outcome is a new partnership. Agents handle mechanical work. Juniors gain faster access to complex systems. Seniors spend less time correcting syntax and more time teaching judgment. Teams build more while investing in people. The career ladder becomes less about years spent typing and more about stages of ownership. The worst outcome is simple. Companies stop hiring beginners. Seniors supervise agents until the seniors become scarce. Generated code multiplies. Understanding concentrates. Training shifts to unpaid individuals. Opportunity narrows. The industry becomes productive, profitable, and brittle. Both futures use the same technology. The difference is organizational choice. This is why the phrase "to destroy" matters. Coding agents are not destined to destroy the junior career ladder. They make destruction economically easy. The ladder survives only if companies decide it has value beyond today's output. A new developer should not wait for the old market to return. The strategy must change now. Use agents. This point matters again here because the context has changed. Do not worship them. Build real systems. Do not infuse generation with understanding. Learn one domain deeply. Operate what you build. Read code written by others. Review machine output. Study security. Write clearly. Learn databases, networks, and systems beneath frameworks. Create evidence of responsibility. Show what failed and what you learned. The person who can only produce code competes with machines. The person who can own outcomes works with them. This advice sounds demanding because the market is becoming demanding. The easy entry may be disappearing. A stronger entry can replace it. The first employer must also change. Do not hire a junior as a cheap pair of hands. The agent already offers cheap hands. Hire a junior as future judgment. Give the person context. Responsibility. This point matters again here because the context has changed. Mentoring. This point matters again here because the context has changed. Time to understand. Use AI to accelerate learning. Cannot use AI to avoid teaching. The investment can create a loyal, high-leverage engineer adapted to the company's system. In a market where everyone competes for seniors, this can become a strategic advantage. The companies that continue training may look inefficient for a few years. Then they own the talent supply. Competitors rent experience at rising prices. The same logic that made proprietary data valuable in AI can make proprietary human expertise valuable. A company can create it internally. The latter becomes a moat. This is the business argument for saving it. Not nostalgia. Not charity. Competitive survival. Software has always been a human system disguised as a technical system. Code reflects communication. Organizations. Incentives. History. AI coding agents make the technical production layer faster. They do not remove the human system. They can make its weaknesses more visible. A vague company produces vague prompts. A fragmented organization produces fragmented software. A manager without product judgment creates more useless features. The agent amplifies whatever surrounds it. Strong teams become stronger. Weak teams create mistakes faster. Juniors are part of how teams renew and challenge themselves. Removing them can make a company efficient and stale. Beginners bring new tools, questions, and habits. They often adopt technology faster than senior employees. The junior using an agent well can teach the senior. Mentorship can become the way. The senior provides judgment. The junior provides AI native workflow. Together, they outperform a team of only one type. This may be the strongest reason the latter will not disappear completely. Companies need people who grew up with the tools. Today's seniors learn in software without autonomous agents. Tomorrow's engineering leaders must understand agent orchestration naturally. The best way to create them is to hire today's junior. The junior is not obsolete. The old job description is. Do not hire someone to manually write boilerplate. Hire someone to become excellent at directing. Evaluating intelligent systems, the first task should reflect that goal. The career ladder can be rebuilt around AI. Step 1 is understanding. Step 2 is verification. Step 3 is ownership. Step 4 is system design. Step 5 is organizational judgment. Coding remains inside every step. It is no longer the whole step. The title of the documentary contains a warning. Could destroy. Not will destroy. The distinction is the entire story. Technology opens a path. Economics pushes companies toward it. Institutions decide whether they follow it blindly. The junior career ladder was an accidental product of a labor-intensive software industry. The next ladder must be intentional. It will not survive because companies need beginner typing. It will survive because companies need future experts. That need is real. The danger is that it arrives later than the cost savings. The agent sends a pull request today. The talent shortage arrives years from now. Good leadership connects the two. Bad leadership celebrates the first and ignores the second. The most important decision in AI coding may not be which agent a company buys. It may be whether the company continues hiring people who are not yet experts. The answer will shape more than career. It will shape who understands the digital world, who can build independent systems, who can challenge the platforms, who can repair failures, who becomes the next architect. If the doorway closes, software engineering becomes a profession without a beginning. A small number of experienced people supervise increasingly capable machines. The code keeps flowing. The knowledge does not. That is the real risk. The career ladder was never made of code. It was made of chances. A chance to fix the small bug. A chance to ask the embarrassing question. A chance to receive a difficult review. A chance to break something that could be repaired. A chance to carry a little more responsibility next time. I can take the task. It should not take the chance. The companies that understand this will build the strongest engineering organizations of the next decade. The companies that do not may discover that the cheapest junior developer they ever hired was the machine. And the most expensive mistake they ever made was believing they no longer needed beginners.